Hey everybody, how's it going? So we are looking at a Yamaha HS8 today, and this particular monitor, the customer is complaining that there is no sound whatsoever, so they've labeled it as dead. So the speaker is here and the module is out. There's a couple simple connections on the back here. There's one connector that goes to your LED at the front, and then that's here, and there's this connector here which is for the tweeter and the woofer. So aside from the LED being disconnected and the speakers being disconnected, everything on the actual module itself is all connected. So right here, if you look, this is the preamp board, so it's basically preamplification, and all of your tone shaping occurs within this board here. And then you can see here we have what looks like a power board. So there's some bulk capacitors there which are responsible for charging. They're like big batteries. They'll charge up and they will power those pins that are near the heat sink here, a bunch of power amp chips, and that will essentially send whatever signal is being sent through the preamp, which comes into the power board from this cable here. It will amplify that signal depending on whatever volume level you have it set at. So we can also see there is a power input section here, AC in. There's a fuse on this board, as well as a capacitor of some sort, and then there's the filter, and right here is where the power passes into, or from the transformer into, or sorry, from the input of the AC into the transformer. The transformer does its tricks. Either it down regulates most likely the AC voltage coming into this board here, and then this board somewhere on here will be rectification, because all of the components that are within this area need a DC signal in order to operate. So what we can do is we can check the AC that is on these pins here, that is coming from this particular board here, right? Or sorry, from the transformer itself, not the input board, from the transformer. So we're going to check for alternating current here, because this is where that cable is connected, to make sure that we actually have AC moving into this power board. Okay, so we have the power cable connected now, and it's at, basically 120 volt line level, and the device is currently off. So what we can do, generally what you would want to do most likely in a situation like this, is if you have a supply that has a limit feature on it, you would turn it on limit, because if there is any short occurring within the circuitry here, limit protects the runaway current. So we can keep it on limit for the time being, because there is no switch mode supply here. It's a linear supply, right? There's a big transformer. We don't have to worry about if you have this on limit setting and you're trying to work on a switch mode power supply, 90% of the time it's not going to operate correctly. So anyhow, in this situation we'll be okay. So what we can do is we can actually just turn the device on here, and we can review the amount of current that it's pulling. So on limit, it looks like it's pulling about 0.3 amps, so 300 milliamps. I'm just going to switch it over to on. So that's a good sign. I mean, it means that the device is actually sinking current right now, and we can continue troubleshooting. So as you can see, the chassis is grounded here. So what I'm going to use that as a reference point. I have my multimeter set to alternating current, and we're going to check to see whether or not there is any voltage on these pins here. So this is looks like one side of the tap, or sorry, there's the tap in the center most likely, and this is one side, and this is the other side. So we're on the secondary of the input transformer, and if I put my lead there, I can see that we have about 22 volts. So step down transformer, and we have another 22 volts, and then if our guess is correct, So should be nothing. So that's the center tap there of the input transformer. So there is voltage passing into this board. Now we don't have the schematic, so we're not exactly sure how much voltage is supposed to be, alternating current is supposed to be applied to this board, but we are going to continue on the assumption that that is an okay amount to be regulated further. One thing that I forgot to mention, this is something you can do really quickly just to test the actual speakers themselves, is you can put your meter on ohm test, and then the tweeter on this is, excuse the dog, 8 ohms, and the woofer is 4 ohm impedance. So because these are not connected, like you can see that the tweeter has its own line, blue and yellow. It's you know, serial directly into this power amp board, and then that 4 ohm has its own line as well, black and red. You can check the impedances of the speaker. It's sometimes worth checking just to make sure that they're reading correctly. They're not, you know, burnt open from an overcurrent situation or whatever the case is. So I'm gonna check right now. And of course, this impedance, it's impedance, not resistance. So it's not going to always, it's dependent on the frequency and the signal that's being applied to the actual speaker itself. So we're measuring right now, we're measuring the tweeter, which is supposed to read 8 ohms, and we get a 6 ohm readout. So we're going to say that that's okay because it's, you know, close enough to that 8 ohm impedance, and we're measuring with a multimeter. And then I'm going to do the same thing on the woofer. And the woofer is supposed to be 4 ohms, and it's reading 2. So that is strange. You would think that it would be a little bit higher. So what we can do in this situation is, it's possible that the woofer is actually burnt out. So we can check the operation of the actual woofer itself by feeding an amplified signal just into the woofer without using any of the board, and we're going to do that in a second. So what we have here is a powered mixer, and I have an oscillator running into it right here that's set at 10 times 100 hertz, so it's a 1 kilohertz signal, and then I can change the amplitude of that signal being fed into the mixer over here. So I'm going to feed a signal in, and I have the gain set up on the mixer to be able to push that, you know, bring up the original level of the signal going into the mixer. And then I have my fader here, so I'll set the output to around here. And then I have an audio cable. Make sure you know the difference between an audio and an instrument cable coming from the powered output of this speaker, and it's traveling into connectors here that I have set up. You know, tip is positive, and then the ring is neutral, and then I have that being fed into the woofer. So let's check to see if the woofer is operational. So it doesn't seem like there's any issue with the woofer itself. Now let's check the tweeter. So now we have the exact same setup here, except the output is connected to the tweeter instead of the woofer. Every speaker has its own frequency response, so I'm gonna assume, I don't know what the frequency response of this particular tweeter is, and I don't know what the crossover is coming out of this board, but let's just set the signal to, I don't know, like, we will set it to, let's say 10,000 hertz. And then I have the amplitude set up here, and I'm just going to test the tweeter now. So I'm not sure if the phone is picking that up, but I can definitely hear an output there. I'll sweep the signal. So the speakers are operational, so we know that's a quick check that you can do if you have all of the required gear. So we know that the issue lies somewhere here. So we're moving back to troubleshooting the actual amp module itself. One thing that I would like to make mention of is that these bulk capacitors can store a lot of DC voltage. Like, they're big batteries, so you want to be really careful when you're troubleshooting anything like this, because even though it's powered off right now, those are likely still holding a charge. So what you can do is you can take, if you're working on something like this and you're worried about getting shocked, you know, even when it's off, good practice is to actually take a decharging tool. So basically just a large wattage resistor at a lower value, which is built into this here, and basically just put it across these nodes here. So put it across the capacitors themselves, or put one end of the lead to ground and then the positive end to the positive side of the cap in order to discharge it, and that way you know that you know, you don't have any excess voltage kind of lurking about in your circuit, and you don't blow anything while tapping around. So anyways, I'm going to do that really quickly, just decharge both of these, and then what we can do to make sure everything is good is we can set our multimeter to DC, and then we can check to see if we have any voltage remaining in the caps. I'm not hearing any clicks, so it looks like we're okay. And yeah, just do that every time you're working with something that has large capacitors like this. Even if it's powered off, there can be residual electricity within the circuit, and if you accidentally, you know, take your lead and touch 2 pins on a power amp chip, let's say, you can short them with that excess voltage, or you can hurt yourself, so be very careful. So now what I'm going to do is, this is turned on and I have the lead set up on ground here, one of the leads on ground, and then I'm going to check to make sure that the actual caps are, you know, charging correctly. So it looks like on this side of the cap we've got negative 30 volts, and on this side we have positive 30. So assuming that the chips that are in here, some of the power chips require a positive and negative voltage, we're gonna go with the assumption that the caps are okay, so we will continue troubleshooting. So now what we can do is we can check to see, see how those chips are mounted to the heat sink there. We know that those are going to be the guys that are responsible for amplifying the signal. So what we can do is we can check to make sure that the supply voltages that are being provided from the capacitors are there. So we're going to want to make sure that we have a positive and negative supply based off of what we saw in the capacitors running to those chips. So again, don't know the layout of this particular chip. You can probably find a data sheet for it if you're able to figure out what the chip is, but I'm just going to start kind of poking around pin by pin here, and we'll see if we get a reading, in our, you know, a supply reading. So this pin here is showing negative 30, and this pin is showing positive 30. So this chip appears to be, it has the power being supplied to it. So we're going to check the second chip, and that's got negative 30, and this has positive 30. So we know that there's no issue with the supply being provided to the chips. So now we're going to do a little bit of signal tracing, and basically we're going to make sure that the signal is actually passing from the preamp board into the power amp board. And we are going to set our oscilloscope to, let's say, right here, I don't know, 1,000 hertz. We're feeding that signal into the input of the preamp, and then we're going to power this on. We got an oscilloscope set up here, an old school analog oscilloscope, and basically I'm going to use the probe to test the pins on this particular board that are going into the power board to see whether or not the signal is actually making it to the power amp board. So again, I don't know which pin is responsible for passing signals. Some of these are responsible for passing power to the preamp board in order to power the operational amplifiers, but we're just going to look, we're going to poke about here and see if we can find a pin where that signal is passing. So I'm looking at the oscilloscope right now, and every single pin that I am probing, 1, pin 2, pin 3, pin 4, and pin 5, I see no movement whatsoever. Even if we change the voltage division here, we might see a little bit of residual noise. This is my finger, so you're gonna see a little bit of right there, but anyhow, again, checking 2, 3, 4, and pin 5. There's literally nothing going on. So at this stage of the game, we can probably conclude that the issue lies within the preamp somewhere and not in the power amp. So one quick thing that I forgot to mention, and this might seem really obvious, but before you start probing around, you know, in something like this, it's generally a good idea just to do a visual inspection. Like sometimes these large capacitors, they're generally like, you know, crappy Chinese origins or things like this. They can fail sometimes, so check to see if they're bulging or leaking. You can check to see, like this board, it looks like the soldering is pretty solid on it. I think it's yeah, it's not double-sided, but you know, inspect the soldering and see if there's any cracked solder. Sometimes cracked solder can lead to connection issues and supply issues and these types of things. So do your due diligence with a visual check before you do anything, and then start messing about. But anyways, the next step is we are going to check to see, once this is powered on, whether or not the op amps, some of the ICs that are on here, those little black boys, they have power going to them from passing from this board into the preamp board, because if they don't have power, then no signal is going to pass through and we're not going to see any output to the power board. So let's check that in a second. So now what we can do is this power board here, we know that the high power supply for the power amp chips, the 30 volts DC, is present. But we're going to probably look for like a positive and minus 15 volts on the 4th and 8th pins of the operational amplifier. So if I poke the 4th pin here, this particular op amp has negative 14 volts being supplied there. And if I check pin 8, we're at 172 millivolts DC. So it seems like the positive supply is not making it to these operational amplifiers. So the issue likely lies in the low voltage positive power supply coming from this board over here. So moving back to the power board, we can see that this is, after poking around for a little bit, I was able to find the negative 14 volt supply that's being passed to this board is coming from this particular cable here. So, and we know that that's present on the preamp board, so that negative 14 volts is there. And poking around here, all of these other pins, like I don't see any. So this pin right here should be supplying that positive 15 volts, but we're getting millivolts. So we know that the positive supply, low voltage power supply that's coming from this board is faulty. So the way this has been designed is a bit of a pain in the butt to get into. Anyhow, I'm not going to bother at this point stripping everything apart. You can see the bulk capacitors there. You can see a bunch of other caps responsible for filtering, and there is the power amp chips that are attached to the heatsink. If you look right here, there's 2 chips that are mounted to the inside of those heat sinks there, and those are most likely voltage regulators for the positive and negative supply. So what we can do is, without taking anything apart at this point, we can look and we can see right there, there's 3 pins for either section, 1, 2, 3, and 1, 2, 3 over there, and we're going to check to make sure that those are actually providing the correct voltages for the preamp board and the chips that are on this board. So let's check to see that. Okay, so doing this is going to be a little bit difficult, and bear with me here, but anyways, this is pin 1 on one of the regulators, which has that, I'm assuming, is ground because it is showing no volt DC. Pin 3, which is showing negative 14, so we can assume that the middle pin is actually receiving that negative 30 volts, which we see there. So this regulator is functioning correctly. It's providing the negative side of the supply. Now U1, we're checking pin 1 because this is a different layout. It's a different chip. Anyways, this is supposed to down regulate 30 volts into 15 volts. So we have 30 being provided to that particular chip. And on pin 3, which should be outputting, pin 2 is ground. If you look here, nothing. Now pin 3 should be providing positive 15, but we're getting millivolts. So we know that there's something either going on with the chip. The chip could be bad, the regulation chip, or there could be something on the other side of the regulator that has shorted and is pulling the voltage down to that very, very low amount. So let's do a little bit more checking here. So what I did is removed the power amp board from the actual module itself. The heatsink is still attached to both of the power amp chips here, so if we run it, we should be okay to run it for a long period of time before, you know, anything blows. And unfortunately, I don't have the schematic for this particular monitor, so I'm going to do a brute force technique, and the regulator that is not providing the correct voltage to the preamp board for the operational amplifiers, I'm going to just remove that. Again, it's better if you have a schematic because you can actually check the components down the line and check for shorts and these types of things. But for the time being, we're going to do a brute force replace of that actual regulator and see what happens. And I apologize here, my setup is not pristine for recording videos like this. So anyways, this is the bad boy that's responsible, or we think is possibly responsible, for the issues related to this supply. So got my soldering iron, a little bit of solder, it's got lead in it, and this is like lead-free solder, right? So to remove these types of things, sometimes it's easier to just, I'm looking now, and actually there might even be cold crack solder on that. I highly doubt it, but anyways, I'm gonna add some leaded solder to make it easier to remove. Here's the heat sink for this chip. I'm gonna add to this. Okay. It's been removed along with the heat sink, and we can actually see the chip a little bit better now. So you can, you know, if you're wanting to, you can do a little bit of research on that. So this voltage regulator here, we have the data sheet pulled up for it, or the equivalent of it. It's basically an LM7815A. So we're gonna go through here and we'll see that the 7815 is a 15 volt regulator, and all of your amperage characteristics and everything that you need to know, including the pinout, and these types of things are all displayed. So basically, if you're going to be replacing it with an alternative, you have to make sure that the pinout is correct, obviously, and you have to make sure that the characteristics in regards to, you know, the voltage input, voltage output, amperage, all these types of things are analogous to the chip that is here. Anyhow, we're lucky enough and we have the 7815A on hand, and I am going to check. The manufacturer is different for this, so I'm going to make sure that the pinout is the exact same. It should be, but yeah, we'll go from there. So I checked the operating characteristics as well as the pinout of the new voltage regulator that we installed, and everything is good to go here. Again, excuse the dog, he's a mental case. And what we can do now, just to see, make sure that it was actually the chip and nothing on the output stage pulling that voltage down, as we can check the voltage drop across that. So again, this is grounded. What I'm going to do here is I'm going to go to pin 1, We have our positive 30, and then I'm going to go to pin 3, and we have 15 volts. So it looks like we got lucky in this situation, and hopefully once we put this back together, this preamp will have both sides of the supply that's necessary to operate the op amps, and hopefully everything will be good to go. So let's check. Okay, so the permanent install of that voltage regulator chip has been completed. We have the heatsink back in place. Got everything set and ready to go. So let's test this in a second and hope everything's working. Currently struggling a little bit because, you know, why would you give enough cord to get this in here? So you basically have to like jam that as far forward as you can, and then you gotta have little baby hands or something to get in there. So give me a second. So after struggling with some of the connections a little bit, I managed to get this thing back together. It's plugged in and it's powered on. Now let's see if we get any sound, because before we had no sound. So looks like everything is working here, which is great. We got lucky on this one. It was only the regulator that had gone, one of the regulators. Typically, a lot of these types of electronics have standby circuits, muting circuits, these types of things, and it can get a little bit more complicated in terms of the troubleshooting. But anyhow, this one wasn't too bad, so hopefully you guys learned something. This video was for myself as well, educational purposes. And yeah, if you have any comments or questions, let me know. Take it easy.